welcome to Tennessee's at-home learning series for math. Today's lesson is for all of our 7th graders out there, though all children are welcome to tune in. This lesson is the 3rd in our series. My name is Kayla Anderson, and I'm an 8th grade teacher in Tennessee schools. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them on the Tennessee Department of Education website, which is www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of the others, but it might be more fun if you first go back and watch the other lessons, since we'll be talking about things we learned previously. Today, we're going to be learning about additive inverse and equivalent expressions in mathematics. Before we get started, to participate fully in today's lesson, you will need the table to fill in, which is here, if possible, paper, pencil, and something to write on, a surface to write on. Okay, let's get started. Today we'll be talking about generating equivalent expressions. Remember that equivalent means equal or same. We will be using what we know about additive inverses and order of operations to generate the equivalent expressions. So let's go ahead and jot down some vocabulary. If you'd like to take notes and write down vocabulary as we go along, it might be helpful for you to refer back to as the lesson progresses. It probably won't stay up here the whole time, so if you'd like to write it down now, it might be a good idea. So let's start out with equivalent. And as we just said, equivalent means equal or same. So we're going to be working on creating equal expressions or equivalent expressions. Well, now that we know what the equivalent part of that means, we need to review what an expression is. So over the last 2 lessons, we've been working on expressions, and we've talked about the fact that expressions do not have equal signs. Equations do, expressions don't. So expressions have no equal sign. Okay? Now, something that's new to this lesson is additive inverse. Additive inverse. And additive inverses have a sum of 0. I know it's kind of a lot. I'll pause so you can write it down, but we're talking about generating or creating equivalent, which means equal, expressions, which don't have an equal sign. And in order to do that, we're going to be using additive inverses, which have a sum of 0. An additive inverse is what you add to a number in order to get 0. Another way of saying it is that it's the negative of a number. Now, I know that's kind of a lot to write for additive inverses, so feel free to write down from that what's helpful for you. And I'm going to pause for just a second in case you'd like to jot any of that down. All right, so hopefully you've had a chance to kind of copy some of that down and think about it a little bit. What I'd like for you to do is to fill in the center column of the table, the table's referenced here, with the opposite of the given number or expression. Then I want you to show the proof that they are opposites, and we're going to do the first one together. So for the first one, my expression is 1. Doesn't really look like an expression, but it is because it doesn't have an equal sign. So my expression is 1. The opposite of that is -1. And the proof that these two things are opposites is that when I add 1 plus -1 together, they equal 0. So now it's your turn to copy these things down in the table, to fill in the opposite, which is what this middle column is, and then to give me the proof that they are opposites. So I will pause for a second, here in just a second, so that you can copy that down and work on it. In the last two rows here, which say x plus 3 and 3x minus 7, explain how the given expression and its opposites compare to one another. Okay? So I'm going to go ahead and pause, give you a chance to copy that down and fill it out, and then we'll come back together and go over this. All right, so I hope that you've had a chance to copy some of this down, think about it a little bit. You may not be completely finished, and that's fine. As we work through it together, you can continue to fill in your table. So recall that the opposite of a number, recall that the opposite of a number, say A, opposite of some given number, which is A, satisfies the equation A plus negative A equals 0. So that opposite is the negative of that number, or the inverse, and so that when you add them together, they do equal 0. We can use this equation to recognize when two expressions are opposite of each other. So some number plus its negative or its inverse or its opposite when added together equals 0, which is what we've proved here, that 1 plus negative 1 does equal 0. So let's go ahead and fill some of this in and talk about how these make opposites. So my expression is 3. The opposite of 3 is negative 3. And so to prove that those are opposite, when I add 3 plus negative 3, it does equal 0. Okay, my next expression is negative 7. The opposite of negative 7 is positive 7. To prove that those are opposite, when I add negative 7 plus 7, it equals 0. Okay, now I've got negative 1/2. The opposite of negative 1/2 is positive 1/2. To prove that they're opposites, I'm going to add them together. So negative 1/2 added to positive 1/2 does equal 0. Okay, moving on, I have x as my expression. The opposite of x is negative x. To prove that they're opposites, I'm going to add them together. X plus negative x equals 0. Okay? 3x is my expression. The opposite of 3x is negative 3x. To prove that they're opposites, I'm going to add 3x plus negative 3x, and it does equal 0. Now I'm going to pause for a second in case you haven't had a chance to copy those down, or in case you got those finished but haven't had a chance to think about those last two. Okay? So why don't you, if you're struggling with these last two a little bit, break them down and think about what's the opposite of x? What's the opposite of 3? So what would be the opposite of x plus 3? And go from there. Okay, so for this next to last one, x plus 3. What's the opposite of x? Negative x. What's the opposite of 3? Negative 3. So what can we say about the opposite of adding x plus 3? Well, it's the opposite of the sum of x and 3. So the opposite, it's by adding together their opposites. So the opposite of x, negative x, and the opposite of 3, negative 3. So I'm just taking those pieces and making them opposites of one another. Now another way you could write that is negative x minus 3, and that would be the same thing. So to prove that they're opposites, this one may be a little small, to prove that they're opposites, I'm going to add x plus 3 plus negative x plus negative 3. So x plus negative x and 3 plus negative 3 does give me 0. Okay? And so for the last one there, again, we're going to do the opposites of those different pieces. And so the opposite of 3x is negative 3x. And the opposite of negative 7 is positive 7. So to prove, let me see if I can move this up. So to prove that they're opposites of one another, I'm just going to add them together like we've been doing. So 3x minus 7 plus negative 3x plus 7. So 3x plus negative 3x and negative 7 plus 7 does give me 0. Okay? So I hope that working through that chart a little bit has given you a chance to think about taking the opposite of an expression and adding them together to get 0 to prove that they're opposites of one another. Okay? So now we're going to do some examples together. So if you'll give me just a second, if you want to get some paper, get your paper ready to copy down this example that we're going to do. I'll leave our chart here so that we can refer back to it as we work. So for example 1, we're going to be subtracting expressions. Okay? So example 1, I want you to subtract 40 plus 9 minus 30 plus 2. Okay, so I'm going to pause for you to write that down and kind of think about it a second. Okay, so there's a couple different ways that we can do this. We can either use what we know about opposites. So if we're using opposites, we're going to keep our 40 plus 9, opposite of 30, negative 30, opposite of 2, negative 2. Keep in mind that another way you can write that is to be adding negative 30 and to be adding negative 2. So we're doing the opposite here. We're adding that negative 30 and we're adding the negative 2 there. And so putting those things together, 40 plus 9, 49, plus negative 30 plus negative 2. So 40 plus 9 is where the 49 came from. So now we're going to do 49 plus negative 30, which gives me 19. And then 19 plus negative 2 is 17. So this is using our knowledge of opposites and saying that subtracting 30 plus 2 is the same as adding negative 30 and adding negative 2, using our knowledge of opposites and coming up with 17. Or another way that we could work this same problem is by using order of operations. Let me move this for a second. So if we're going to use order of operations, using this same problem, order of operations tells me that I need to do parentheses first. So for parentheses, 40 plus 9 would give me 49, my minus sign in the middle, and then 30 plus 2 gives me 32. Now that I've done what's in parentheses, I can then go ahead and subtract them and go from there. So 49, take away 32 gives me 17. I know I went through that rather quickly, so I'm going to pause so that you can copy it down and think about it. All right, so hopefully you've had a chance to copy it down, think about it a little bit. Remember that here's our example, this 40 plus 9 minus 30 plus 2. And here we're using our knowledge of opposites, which is what we've been talking about, taking a number such as 1. The opposite is negative 1, and when you add them together, you get 0. So using our knowledge of opposites, that we're subtracting these things, is the same as adding negative 30 and adding negative 2. So as we work through, 40 plus 9 is 49. 49 plus negative 30 is 19, and then 19 plus negative 2 is 17. You could also use order of operations. And order of operations tells me to do parentheses first, so 40 plus 9, 49, 30 plus 2, 32, and then subtracting them we get 17. Same answer either way. Which method is more efficient? Opposites? Order of operations? Think about it for a second. Which one is more efficient? So since we're only using numeric values and we're not using variables or anything like that, the order of operations method seems to be a little bit more efficient for this particular problem. Okay? So now we're going to think about another example and how we can simplify something. We're going to bring in some variables. Okay, so now let's think about how we can simplify this. So 3x plus 5y minus 4 minus 4x plus 11. Right, so go ahead and jot that down and think about how we would simplify that. Okay, so since we can't add or subtract unlike terms, we have to use what we know about opposites in order to simplify this. Okay, so using that bit of knowledge, what we know about opposites, I'm going to give you a second to simplify this and see what you come up with using opposites. All right, so using what we know about opposites, we can say that we have 3x plus 5y. Opposite of minus 4 is plus negative 4. Then we have plus negative 4x and plus negative 11. So using our knowledge of opposites, we know the opposite of negative 4 is plus negative 4. The opposite of negative 4x is plus negative 4x, and of 11 is plus negative 11. So now that we've used our opposites here, we're going to add those like terms together. So 3x plus negative 4x, and if you'd like to rewrite them so that your like terms are together, it might be a little more beneficial. So we have 3x plus negative 4x plus 5y plus negative 4 plus negative 11. And now that we've rewritten them, we can go ahead and combine those like terms. So 3x plus negative 4x is negative x plus 5y, because we don't have a like term to go with that one. And then negative 4 plus negative 11 is plus negative 15. Another way that you could write that is negative x plus 5y minus 15. Okay? I'll pause for you to think about that, look over it, and write it down for a second. All right, so we've done the simplifying, we used opposites, we did the simplifying, but now that we've come to the conclusion that 3x plus 4y minus 4 minus 4x plus 11 is equivalent to we did all of this work to figure out that it's equivalent to negative x plus 5y minus 15 is what we just did. We simplified, we generated an equivalent expression. We had this expression. We used our knowledge of opposites to generate this equivalent expression. Now that we've done all of that, how can we be sure, how can we prove that they're actually equivalent to one another? They don't look the same. So how can we prove that these two expressions are equivalent? Think about it. So if you'll recall from lesson 2, we chose numbers for x and y, and then we evaluated the expressions using those numbers. So if we get the same results for this expression and this expression, when we choose numbers to substitute, then we'll know that those two are equivalent to one another. So what I'd like you to do right now is choose a number that you'd like to use for x, choose a number that you'd like to use for y, substitute that x value in place of x in this expression, substitute that x value in place of x in this expression, do the same for y, and see if you come up with two equivalent expressions. And once you've done that, and you've had a chance to think about it, we'll come back together and I'll walk you through it, and we'll see whether these are truly two equivalent expressions or not. All right, so I hope you've had a chance to choose some numbers, think through it a little bit, and try it out. I'm going to choose x equals 2. Sorry, let me get out of the way. I'm going to choose x equals 2 and y equals 6. Did you also have to choose those same values? No. Any numbers that you chose for x and y should still work. So for this first expression that we started with, I'm going to substitute 2 in place of x and 6 in place of y. Let me put those in parentheses. Again, I'm substituting 2 in place of x. And I'm going to evaluate and see what I come up with here. So working inside these parentheses, 6 plus 30 minus 4 minus 8 plus 11. 6 plus 30 minus 4 does give me 36 minus 4 minus 8 plus 11, which is 19. 36 minus 34 is 32. So 32 minus 19 does give me 13. Okay, now substituting 2 in place of x and 6 in place of y. I have negative 2 plus 30 minus 15. Negative 2 plus 30 is 28. And 28 take away 15 is 13. So yes, both expressions resulted in the same number, so they are actually equivalent to one another. I'm going to pause for a second in case you need to copy this down using x equals 2 and y equals 6. But remember that any numbers that you choose should work here in order to prove that this expression is actually equivalent to this expression, because when we've substituted those numbers in, we end up with the same number as our end result. So I'll pause for a second so that you can copy that if you need to. All right, so great work today, guys. Today we went over how to simplify expressions and how to prove that they are equivalent. So remember that an expression has an equal sign, that an expression does not have an equal sign that an equation does. Remember that equivalent means equal, and how we talked about even though these two expressions don't look the same, using our knowledge of additive inverses, they are equivalent to one another. I hope you're seeing some connections between the two expressions. You sure did a great job. After the video, you're going to have some problems to practice on your own. Good luck and do your best. I really enjoyed doing some mathematics with you today, guys. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Bye.